center given, it's a clue that you might have to use one of the center theorems. So a center is provided in the question. Then you also have the midpoint of Rm. Okay, T is the midpoint. Remember, you are in grade 11. Last year you were taught the midpoint theorem. So the midpoint theorem can also come, okay, in grade 11. Even next year when you are in matric, so you might have to apply it as well. So 2.1 says calculate with reason the size of T1. So T1 is that. Okay? Now, you don't really need to do a calculation to get T1. Okay? So 2.1b and 2.1a. So T1 is equal to 90 degrees. And the reason here, because chord Rm is bisected, the chord is bisected and it's indicated, you don't use the original theorem 1, you use the converse. Line from center to midpoint of chord. Okay? So your reason here will be line from center to midpoint of chord. Okay? That's the appropriate reason for that question. Whenever you are given a question, if it's indicated on the diagram that a chord is bisected, there is no indication of a 90-degree angle between the line from the center and the chord. The reason that you must give is the converse of theorem 1. Okay. Then to get angle O2, okay, we are told that angle R is 50 degrees. And angle R is at the circumference. O2 is at the center. Both angles are subtended by the same chord PM. So we use theorem 2. Angle at center is 2 times angle at circumference. So angle O2 is going to be equal to 2 times angle R. And our reason there is angle at center is equal to 2 times angle at circumference. So angle O2 is going to be 2 times 50 degrees, which is equal to 100 degrees. Okay? Then angle S, this angle here. Again, angle S is an angle at the circumference. It's also subtended by chord PM. Okay? And it's in the same segment as angle R. So you can give any one of two reasons, either angles in the same segment or angle at center is 2 times angle at the circumference. So here I'm going to use angles in the same segment. So you two, can you pay attention? Pay attention and be part of the lesson. So angle S is equal to angle R. And they are angles in the same segment. Okay? So angle S is going to be equal to 50 degrees. Okay? Yes?
Why can we not say that the reason for what we just said is angle subtended by same chord?
Okay. It is true that there are angles that are subtended by the same chord. But what happens is that according to your curriculum in this country, there are some acceptable reasons that you have to use. It is true that they are subtended by the same what? Chord. But how do you write that down? The acceptable reason for that, okay, based on the examination guidelines for the NSC, it will be angles in the same segment. It is true that if you write that they are subtended by they are angles subtended by the same chord, it is true, but you have to follow the examination guidelines in terms of acceptable reasons for grade 12.
So we never use it.
No. You never hear me say angles subtended by the same chord. I will say angles in the same segment based on the theorems. If angles are subtended by the same chord, if they are on the same side, okay, of the segment, means they are equal. So the acceptable reason based on the examination guidelines. Okay, what do you mean by examination guidelines? If you look at the reasons I gave you, because if we would just say a person would give their own reason for any theorem, we would get lots of what? Different ways of writing the reasons. So the department decided to standardize those reasons so that everyone can what? Give the same reason. Okay, so follow the what? All the reasons which you see me writing here, they are based on examination what? Guidelines. And when I introduced the theorems as well, I told you the acceptable reason for each theorem based on examination guidelines. So follow that. Because next year when you write metric, the person who mark your maths paper 2, the geometry, they are used to the reasons from the examination guidelines. So to avoid disadvantaging yourself, use the acceptable reasons I gave you. Yes. That's true. Yes. That's also correct. It is correct. Because already we proved that angle R is half of O2. If angle R is equal to angle S, it means that angle S is half of O2. So it's fine. Right, so if you use theorem 2 to determine angle S, that's also fine. Okay, so any of those two reasons are acceptable. Right, so let's move on to to D now. So P1 is this angle here. That's P1. Okay, now to get P1, in my case, I'm going to use sum of angles in a triangle, but first thing, I'm going to write OP is equal to OM. And my reason here is radii. Okay? Then, I know what O2 is, so it therefore means that P1 will be equal to angle M. And our reason here is angles opposite equal sides.
So, is it not M1?
It's the same as angle M.
But there's M3.
Oh, okay. All right, you are right. Okay, so what I'm going to do is I'm going to, okay, you are right. So I'll call it PMO to be more specific. Okay, that's much better now. Yes. Thank you. In triangle, okay, so you are right there. Then we'll say P1 plus PMO plus angle O2, they add up to what? 180. And our reason there is sum of angles in a triangle. Now we want to calculate P2, but P2 is equal to PMO, so this PMO we can replace it by what? By P2. That angle there, we can replace it by P1. If we do that, we'll end up having this statement: 2P1 is equal to 180 minus 100. Remember, we got our O2 as 100. Yes. Yes. No. Did I say P2? Or it's a mistake? Don't worry about that. What's important is what I wrote here. So this becomes 2P1 is equal to 80. So P1 is going to be 40 degrees. Okay, so that's the answer there. Please be aware that we are calculating P1. So P1 is going to be 40 degrees. So this angle here is 40, and that angle there is 40. And this one is it's 100. So that's 100, and this one is 50 degrees. Okay? Then 2.2 is one of the reasons why I gave you this question. Is TOPM okay, before we move on, is there anybody who has got any questions so far? Yes.
Yeah, I know. I was just
Which one? T1. Okay, T1 is this angle here. Okay? It is an angle created by a line which originates from the center, and that line bisects the chord. So the reason for this, it has to be the converse of theorem 1. Line from center to midpoint of chord. Because it's indicated here that the chord RM is bisected. The chord is bisected, so we use the converse of theorem 1. Can you remove the mask so that I can hear you properly? What? Yeah. P1 plus what? P1 plus P1. You want to change the name of that? Yeah, you can name it as OP, OMP is still the same. As long as the M is the one which is in the middle of the three letters. Okay? Alright. Is there anybody else who has got a question? Okay, if you don't have a question, then let's talk about 2.2. Now, 2.2 it says is TOPM. Okay, I'm going to highlight it. So, we have TOPM. So that's the quad there. The question is TOPM a cyclic quadrilateral? No. Okay? And then it says give a reason for your answer.
because it's not touching
Huh?
they're not touching the
No. Hey, listen, I gave you 3 ways of proving that a cyclic quad is of proving that a quad is cyclic. Your reason for 2.2 must be based on any one of those 3. I gave you 3 ways of proving that a quadrilateral is cyclic. Your reason there must be any one of those 3. So based on the question, which one is the appropriate one? Yes? Which one?
the angles for
Which one? OTM and PMT. No. Remember, they're supposed to be opposite angles. So T1 and PMT are not opposite angles of a cyclic quad. You are on track, but you need to identify the correct opposite angles. Yeah, so it should be T1 plus P1. They don't end up to what? To 180. Are you following that? Huh? Yes? No. Your reason must be based on the 3 ways I told you about. Is Is your mathematics book up to date? It is a bit. Okay, if it's up to date, then go back to the book about the three strategies. If the reference is not up to
It looks nothing.
Okay, listen. If you want to prove that a quadrilateral is cyclic, there are three ways. Okay? You can have the first case. Can you stop talking? If you add this angle to that, if you can get 180, then you can prove that you can conclude that the quadrilateral is cyclic. Also, if I produce that vertex to a specific point here, I'm going to have this exterior angle, it must be equal to that. If you prove that the exterior angle is equal to the interior opposite angle, then you can conclude that the quadrilateral is what? Cyclic. Also, you can have a butterfly. Okay? If you prove that this is equal to that, or that one is equal to that one, then you can conclude that the quadrilateral is what? Cyclic. So for this question here, we don't have a butterfly. So this one is out. The only two reasons that we can give are opposite angles or exterior angle, which in this case will be that one. Do you see that this is an exterior angle? T2. T2 is not equal to T1. Okay, so there are two ways. So the answer here is no. Then your reason, okay, I would say T2 is equal to 90, or maybe I'll just say T2 is equal to T1, and both are not equal to what? Okay, just write T2 is not equal to what? To P1. That's one reason. Another reason, you can say T1 plus P1 is not equal to 180. That's all. Yes? You see, it's very important. All right, I understand where you're coming from. All right, sometimes you can be given a question like this, where you've got a quadrilateral, but the vertices are not on the circumference, but it may be possible to draw a circle around the vertices. It may be possible to have the vertices on the circumference. So you can have what's called an invisible circle. Do you know what I'm saying? So here, we are being asked that are the following points T, O, P, and M cyclic? Are they cyclic? The question is no. Why are they not cyclic? Because this exterior angle of the cyclic part is not equal to P1. If they were equal, then we could draw a circle passing through those 4 points. If T2 was equal to P1, then the quadrilateral was going to be a cyclic part. If T1 plus P1 was equal to 180, then the quadrilateral is going to be a cyclic part. But that's not the case. Okay? So sometimes you can be given, can you stop talking? The bulk of you didn't even do this question. Okay? On Wednesday last week, you threw away all the books and you said no more. And some of you were not here. She wasn't here. On Wednesday. So she had a longer weekend. Okay. All right. Listen, it's very important for you to know going forward that any question which will ask you to prove whether a quadrilateral is cyclic, there are three ways. If the butterfly is not there, prove that the opposite angles add up to 180. Or prove that an exterior angle is equal to an interior opposite angle. If you prove that the exterior angle is equal to an interior opposite angle, then it means that quadrilateral is concyclic, which means you can draw a circle passing through its vertices. Okay. Is there anybody who has got any other question? Is there anybody who has got any other question? Yes? Can you be quiet, please? I need to hear what she's saying. Yes. The answer is a big yes. Alright. Let's carry on. But let's carry on to this now. You are going to see that here. What I just spoke about. Here. Okay? That's why it was better if you had done this question. It was going to be more helpful to all of you. Alright. So in this diagram, PSRM is a circle. So you have got PSRM. That's a circle. Why is it a circle? Because those four vertices are on the circumference. Then SR is produced. By saying SR is produced means you draw SR, then you go beyond the circumference. That's what this word produced means. It's a very common word in geometry. When MN is drawn, so from the circumference here, a line is drawn to join point N, which is outside the circle. Then the first question says, give with reasons 3 other angles that are equal to X. Okay? So, MOS, this angle here, it is an angle at the what? Center. Alright? Now we need to determine 2 other angles that are each equal to X. Okay? You have to find 3 angles that are equal to what? To X. Which one?
P1.
Okay. Just okay. P1 is equal to X. What's the reason?
Angle at center is equal to 2 times angle at circumference.
Yes. Okay, yes, because both angles are subtended by called what? SM. Hey, can you look please? SM subtends that angle at the center. It also subtends angle P1. Do you see that?
Yes.
Do you see it? Do you see it? SM, it's a chord. It subtends angle, which is a reflex, an obtuse one at the center, that is 2x at the center. The same chord subtends angle P1 at the circumference. Do you see that?
Yes.
So, for 3.1, we'll say P1 is equal to half of, well, let me call it half of obtuse, but in this case, we don't have to worry much about half of. We can just write X, and our reason will be angle at center is equal to 2 times angle at circumference. Okay? Are you following there? Can you look, please? Do yourself a favor, you need to look. So P1 is X, our reason, angle at center is 2 times angle at the what? Circumference. Then P1 is equal to S1. Why? Thank you. So this one will be angles opposite equal what? Sides.
You know to say OP is equal to OS.
Alright, we can write that down. So we can write OP is equal to OS, then we say red idea. Okay? It's always better with geometry to provide more information than less information. Are you following?
Yes.
Huh?
Yes.
Then, so we have this one is x, right? This one is also x. So we have two angles now. Which one will be the third one?
Could we say P1 is
What?
is
It will be R2. Why R2?
exterior and exterior.
How do you state that properly?
Just states an exterior.
Huh?
So I've got two. Stating there is exterior angle of cyclic, and can you not say P1 is equal to R1 angle of cyclic?
P1 is not equal to R1, but P1 plus R1 adds up to 1.
Yeah, but like that, that's what I meant.
Yeah, but you see, here we need to identify another angle. If P1 is x, right? P1 plus R1 will give us 180.
So it won't be equal.
So it won't be equal to x. But R2, it's an exterior angle. So R2 is x because it's an exterior angle of a what? Of a cyclic quad. R2 is an exterior angle of a cyclic quad. Therefore, R2 is equal to what? To P1. So, we will say R2 is equal to P1, and both are equal to x, and our reason will be exterior angle of a cyclic quad. Okay? Then 3.2 says express S2 in terms of x. So S2 is this angle here. We need to express that in terms of what? X. Right, it's very easy to do it. Can someone tell us? What is S2 in terms of x? S2 will be equal to what?
Okay, so M1 is equal to S2, right?
This should be equal to N1. Opposite sides
Okay. There are two ways of getting the value of S2. Two ways. Do you agree with me that PM is a diameter?
Yes.
Yeah, an angle subtended by a diameter at the circumference is equal to what? 90 degrees. So S1 plus S2 is equal to 90. So we can write here and say PSM is equal to 90. Our reason will be angle in a semicircle. Okay? But we know already the value of S1, isn't it? So therefore, we can say S2 will be equal to PSM minus S1. And this will be equal to 90 degrees minus x. Okay? This is one way. Another way, which is a longer way, is to subtract 2x from 180. Okay? And then you divide the answer by 2 because M1 is equal to what? M2. So it will be like this. S2 will be equal to 180 minus 2x all over 2. Okay? Please, I'm just giving you like a shortcut, but there's a proper way that you have to write. You have to write OS is equal to OM, then you give your reason, red eye, then you say S2 is equal to M1, angles opposite equal sides, then S2 plus M1 plus 2x is equal to 180, sum of angles in a what? In a triangle. Then you solve. When you solve, you get to this. So that you end up getting 180 divided by 2 minus 2x divided by 2, and you get 90 minus x. Okay? You can go home and try and do it properly, but you must get that. Okay? For now, I'm just going to stick to what I did here. Are you following? In a month's time, you'll be writing your geometry paper, right, with your trig, which you can do that. So, I can write here, O1 is equal to 2x. Okay, this is given. Okay, therefore, R2 is not equal to O1. Okay, because, okay, well, okay, here I think I'm providing too much information. Let me not do that. Okay, let me not put that because. Okay, if you want, you can just state that R2, which is an exterior angle, is not equal to the interior opposite angle. But this is fine. Okay, so I'm gonna stop here so that I can get my what? My 4 marks. Okay? Yes. I wrote false. Why is it false? Because R2 is x, I proved it. O1 is equal to 2x, it was given. Therefore, these two are not equal. Because they are not equal, it therefore means that SRM, you can write here SRM is not a cyclic part. Okay. What? If you want another way, you can say R1 plus O1. They don't add up to what? 180. Are you following?